hopefully you've had an opportunity to try to determine the chemical formula for this perovskite structure that's a superconductor. It's got a number of different atoms in it. It's got barium, yttrium, oxygen, and copper, so that's 4. And it's got a pretty big unit cell, honestly. So let's do first a little reminder when we're trying to evaluate these kinds of unit cells and determine a chemical formula. If something is in the center, it'll be a full atom. If it is on a corner, it'll be 1/8 of an atom because it will be shared with 8 other unit cells. And so here's an example of a corner atom right here. And then there are going to be atoms that are on edges. That's not how you spell edges, though. Those are going to be 1/4 of an atom. You'll see them, here's one right here. It's going to be shared with 4 other unit cells rather than 8. And then we also have faces. These are going to be 1/2 of an atom. They're shared with just 2 other structures. So an example of one would be this one right here. So it's going to be part of this unit that we're looking at, and then one that's right on top of it. So what we're going to do is go through this atom by atom and try to determine what the total number of atoms in this unit cell are as we go through it. So I'm going to do this to make sure that we can see this structure really well, or I can. So let's go ahead and start with this, and let's start with the easy ones, the barium and the yttrium that are in there. So my barium is going to be these blue ones, and so I can see one here and one here. And those look like they're right in the center of the unit cell. And I know it can be kind of hard to tell, but so there's 2 of these total, but I'll show you something in a second. You have to kind of get used to looking at these in 3D. The yttrium, we only have 1 of right here in the center. So it kind of has this pattern where it goes barium, yttrium, yttrium through the unit cell. And so I've got 1 of these. And so another way to look at this is, I'm going to change up the screens, pause for. So here's actually a model that we can manipulate of the same structure we were looking at. And unfortunately, the colors have changed, but now I can rotate it around. And so those blue balls were our barium. The red one was our yttrium. And now looking at the oxygen, those will be the white balls, and our copper will be the yellow ones in this structure. And so if I want to look at this just face on, so it's very sensitive. There we go. It's the best as I can get it. We can start to see a little bit about this structure, that we have copper on the top corners. You get sorry, my spotlight isn't working. We have copper on our top corners and the bottom corners. And then they're also in the center here as well. And we have then our oxygen occupying these edges around the top and the bottom of this, with then a couple of oxygen atoms that are going to be in the face of the structure in the middle. And so here, I'm going to move this around for a little bit so you can get an idea of it. And I'll put a link as well in this video so you can play around with this yourself and kind of prove to yourself the structure that we come up with. So now that we're back at our structure we were working with before, where we have already identified 2 bariums and 1 yttrium, let's focus on the oxygen. So these are in red on this structure. And there's a couple different types of oxygen atoms in this. I'm seeing ones that are on edges and ones that are on faces. So I'm going to highlight them separately. So on our edges, these are going to be shared with 4 other unit cells. These ones on the top and the bottom. So I've got these 3 right here, and then another one on the top and another 2 here on the side. So I've got 6 that are on the top of this structure, and then I'll see a mirror of that on the bottom, and there'll be another 6 atoms that are on an edge shared with 4 unit cells total. So that's going to give me, so this is for oxygen, 12 of my oxygen atoms that I'll have only a fourth of inside the unit cell for 3 atoms. Then looking at oxygen more, I'm going to highlight these ones in pink. There are some that are only going to be shared with 2 because they're on a face of it. And so this one right here would be on an edge if we were just looking at a unit cell that stopped at that top box. But because that doesn't describe a repeatable unit and it's larger than that, these are actually going to be on a face. And I've got 1, 2, 3, and 4 here on the top, and then 1, 2, 3, and 4 on the bottom. That's going to give me a total of 8 atoms that are on a face, which that's going to give me half an atom each for a total of 4. So I'm going to add these together. I'm going to have 7 atoms of oxygen in this structure. Now we're going to look at copper. I'm going to do a little erasing to make this easier to see. The copper atoms are the small brown spheres in this structure. And our job, just like with the oxygen now, is to count those up. So we have 4 on each corner. Let me highlight them. 1, 2, 3, 4 on the top and the bottom. So those will each be for a corner. They'll be shared with 8 other unit cells. So I've got 8 atoms that I have 1/8 of each for a total of 1 atom for those parts of the layer. And then my other copper atoms are going to be on edges shared with 4 others. So here's an example of one that's on an edge. In that plane, that lattice plane, I have 4 of those. And then I have another lattice plane of those edge copper atoms right here. So I have 8 atoms of copper that I have a quarter of each, which will be 2 for a total of 3. So now that I know the number of atoms in my unit cell, I can easily create a chemical formula. I'm going to have 2 barium atoms for every 1 yttrium atom, 7 oxygen atoms, and 3 copper atoms.